Here's the second half of 1-6, all about solving absolute value inequalities. I will say this is the trickiest section of this chapter. So we're going to be able to solve absolute value inequalities. Write this down. When solving absolute value inequalities, keep your GOLA. It's kind of like goal, it's a play on words. Keep your GOLA in mind. So this is something that I tell students to help them remember whether we're going to use or and this is only used when we're solving absolute value inequalities. It is not used for absolute value equations. It is not used for regular compound inequalities. It is only used for absolute value inequalities. And it's kind of like FOIL. It's a way to help you remember a process. It's not meant to replace your conceptual understanding. And what it stands for is GOLA, greater than or less than and. So if you have a greater than or equal to symbol, put that in parentheses. Greater than or equal to or less than or equal to symbol. So with greater than, whether it's this way or this way, and with less than, whether it's this way or this way. With the greater thans, we use or, and with the less thans, we use and for those compound inequalities. Okay, and we want to make sure to change the sign depending on whether we want a negative option. Okay, so think about the absolute value of x being less than 3. If you think about values of x that would make sense here, it would be 3 or negative 3, right? Because 3 has an absolute value of that is less than 3. And then the absolute value of negative 3 would also be the biggest number or the lowest number that we could have without going over this. Okay, so think about it this way. This is a less than symbol. Less than is going to have an and because of GOLA. Okay, so less than and x is going to be less than 3, and so I just took my x, I left my symbol the same, I took my right side and I left it the same, and now I'm going to take the negative part, the negative option, and I'm going to flip the inequality symbol. That's how I set it up, okay? So x is less than 3 and x is greater than negative 3, meaning if we set this up as a compound inequality, it's going to look like this. Okay, so then when we graph negative 3, negative 2, negative 1, 0, 1, 2, 3, we want open circles above negative 3 and 3, and x is trapped in between. Okay, because think about this way, if we go down here to like negative 6 has an absolute value of 6, which is not less than 3, so it makes the original inequality false. So that's some intuition behind why we want an and inequality for less than. Okay. Example 2, we're going to solve this inequality. The absolute value of x is greater than 5. Graph the solution set on a number line. So this is a greater than, so this is going to be an or. Okay, so x is greater than 5. I just kept the symbol the same. I kept the number the same. Then I'm going to write the word or x, and for the negative option, the negative case, I'm going to flip the inequality symbol to a less than, or x is less than negative 5. So what does this look like graphically? Picture here we have a negative 5, and then somewhere up here we have a 5. We have open circles for both. And then x is greater than 5. That's going to be an array facing this way to the right, and x is less than negative 5 is going to be array facing to the left. For a multi-step absolute value inequality, we have to solve first, then graph. So when setting it up, we only set up the cases once the absolute value symbol is all that's left on one side of the inequality. So 6x minus 5 is greater than or equal to 13. This is a greater than, so we're going to use or 6x minus 5, I'm going to flip the inequality symbol for the negative case. 6x minus 5 is less than or equal to negative 13. And then now let's solve from here. If I add 5 to both sides, I get 6x is greater than or equal to 18, meaning that x is greater than or equal to 3. Or, in the negative case, if I add 5 to both sides, I get 6x is less than or equal to negative 8. Divide by 6. I do not need to flip the inequality symbol because I'm dividing by positive 6. And then x is less than or equal to negative 4/3, which is approximately negative 1.33. That's going to help us know how to graph. Okay. So we have an OR inequality. Let's place our endpoints approximately where they would be. So for negative 4/3, we want a closed circle. And if it's less than that, so we're going to have a left-facing ray. And then for x is greater than or equal to 3, we're going to have a closed circle and a right-facing ray. Okay, so it takes a little bit of getting used to. Look at your practice problems, look at Alex's problems. Let me know what questions you have.